Bismillah ar-Rahman ar-Rahim. Welcome to lecture number 11 for the course CS 325. We will continue our discussion on pandas. We will see how to perform different functions in pandas library. We have already discussed different functions that are used to manipulate data, but we will continue and we will see different distributions, like how to perform different distributions like normal distribution or binomial distribution in pandas library, and how to perform hypothesis testing. And we will also discuss assignment 3 and 4. So let's go to our Jupyter notebook and start discussing the code. So this is the distribution in pandas. We first import pandas library as PD and NumPy as NP. I don't know why it is taking time. Yes, it's executed. Now we create a random binomial distribution. So np.random binomial 1 0.5, and it creates 1. Then we create np.random binomial 1000.5 divided by 1000, and it's 0.518. Let's say we have a variable chance of tornado 0.01 divided by 100, and then we create a binomial distribution np.random.binomial 100,000 and chance of tornado. Here we have given it 0.5, but here we are giving it as 0.01 divided by 100. And you see how the values are changing. Let's say we have chance of tornado as 0.01, np.random binomial 1, chance of tornado 100, I think 1 million, and it's one tornado event. What is tornado? You can read about it. We have you probably have studied this in statistics. The binomial distribution you have studied in statistics. So just if you don't remember, just go through your statistic book and try to understand these concepts. Here we are discussing how to perform these operations in Python. So 2 days in a row, let's say this is a variable, we say it 0. For j in range 1, length tornado events minus 1. If tornado events is equal to 1 and tornado events j minus 1 equal to 1, then 2 days in a row plus equal to 1. So tornado back to back, these many tornadoes back to back in these many years. So 2 days in a row will be the number of tornadoes, and these many 1 million divided by 365 will be per year. So let's try to execute it. So you see these many, once you execute this code, so these many tornadoes back to back in these many years. You can do uniform distribution. So np.random.uniform 0 1, and we execute it, and it's this distribution. We can change the distribution to normal distribution. So np.random 0.75, and this is the standard deviation formula. You can go through statistic book and try to understand the standard deviation and normal distribution and uniform distribution. So let's say this is the distribution np.random.normal 0.75, size is 1000, and we perform this standard deviation. So np dot square root, np dot sum, np dot mean, distribution minus distribution to the power 2 divided by length of distribution. So this is the performing standard deviation using normal distribution. Or you can perform it simply like np dot standard deviation distribution, and it should give the same result. Now there is a package in Python. This is called SciPy. SciPy means science Python, science operations. So import SciPy.states is states, and we say states dot kurtosis distribution. It gives us result. We can have the skew distribution, so states.skew. So with this state, this SciPy state function, we can easily perform different operation. This is skew distribution, and this np.random.chi-square 2 and size, and this is the variable that is having this value, and we perform skew distribution on this one. And we can have another one with a different value. This is for 2, this is for 5, and we can perform the value for this one, and it gives us different results. We can plot. So matplotlib, we will discuss matplotlib in detail, but matplotlib inline, it will allow us to render the graph in web format. We import matplotlib, import matplotlib.pyplot as plot. We can say plot.histogram, and then the formula for chi-square df2 and chi-square df5, number of bins 50, histogram type step, label 2 degrees of freedom and 5 degrees of freedom, and we can print the legend, plot.legend. Location is upper right. So this is the distribution. This is one distribution with the 2 degree freedom, and this is the 5 degree freedom. Okay, so that was about distribution. We can have hypothesis testing, like different types of tests that we can perform. So let's let's load the data. df is equal to pd.readcsv grades.csv, and we can print the df.head, and it has different data. This is the index, this is the student ID, and assignment 1 grade, assignment 1 submission, and assignment 2 grade, assignment 2 submission, and so on. So different grades data is stored here. We can see the length of the df 2315, and we can say early df assignment 1 submission less than equal to this date, and late df assignment 1 submission greater than this date. So this is early and late submission. We can have early.mean. So this gives us the result: grade 1, grade 2, grade 3, grade 4, grade 5, grade 6, and this is the mean. And we can have late.mean, and it's different than this one. We can have different tests. So we import from SciPy import states.tTest, and ind is just to see the. So this is the t-test. So this is the description, and it basically calculates the t-test for the means of 2 independent samples of scores. And different description is given. You can go through it and try to read for yourself. Now let's perform t-tests on the early and the late, and it will give us this one. So this, the p-value is this one and statistic is this one. We can perform t-tests on early and late for assignment 2, and we can know its p-value and statistic, and for assignment 3, and the p-value is this one. So this is how you can perform different t-tests. Again, t-test is something that you have discussed in statistic. In this course we only see how to perform t-test in Python. So I demonstrated the code for performing t-test and how to get the p-value. But what is t-test? Why do we need t-test? Go through your statistic book and perform t-test, or just look for the description of t-test. Now, so that was for the lecture. For the assignment, so you are going to have two assignment 2 and assignment 3 and 4. Okay, so maybe we can close it and just restart it so we get to our assignment. So this is assignment 3. It's basically more about pandas. So all these operations that we have done in week 3 and week 4 you get in assignment. So this is question number 1. We will load this energy indicators data and we will process, this different description is given, and the detail of question number 1 is given here, and this is the answer. So just write your own answer and compare your answer with this one. So this is answer 1, and you can confirm it in this one, and answer 2, question number 2, and the answer is given here. So you can write the code. You just write your own code and try to compare the solution that is provided here. I'm not going to explain the code, so you better give it some time and try to understand the different operations in the code. So this is question number 3 and question number 4 and question number 5. So this is what we are computing. We are computing the mean. Question number 6 and 7 and 8 and 9 and 10 and 11. Question number 12, 13 and an option. So all these questions, I will provide you this solution file. Just go through it first, try to understand the question and try to write code by yourself. Once you write the code, you compare your solution with the code that is given here. Now let's see assignment number 4. This is about hypothesis testing. So just go through it. There are different questions are given, and actually it's one data set, and we perform different tests. So this is the start, recession start and recession end. And we perform this run t-test. So just go through the code, try to see. I will share this assignment 4 solution with you. So just try to understand the questions and try to write the code. Once you write the code, you compare your solution with this solution. So that was about pandas. Make sure that you complete all assignment to understand pandas. We will move to a new topic, and that is about plotting and charting. So before we start plotting, we discuss some theoretical concepts. So these topics, these slides are taken from this book, The Functional Art, an Introduction to Information Graphics and Visualization, and this is by Alberto Caro. So they have discussed the visualization wheel. This is what the visualization wheel is, and it has different attributes like abstraction, functionality, density, multidimensionality, originality, and novelty. If you stay on this part of the wheel, you are getting more complex and deeper figures. But if you go to the other side, redundancy, familiarity, unidimensionality, lightness, decoration, and figuration, this is more intelligible and shallower. So you see, this is multidimensionality and this is unidimensionality. They are opposite. If you go to the multidimensional, you get more complex and deeper images. If you go to the unidimensional side, you get more intelligible and shallower. Similarly, originality and familiarity. Originality means that you use new concepts that are not before, which will be difficult for people to understand. But if you are using familiar pictures, then it's easy for people to understand. Novelty and redundancy. Novelty means that you are using the data, you explain the data only once. Redundancy means you explain the data multiple times and multiple graphs. And abstraction and figuration, like you get more abstract, it will be more complex, but if you go more real world object, it will be easy to understand. Functionality and decoration. So if you get more decoration, it's more intelligible and shallower, but if you give more functionality, more functions, it's difficult to understand, it's more complex. Density and lightness, you get dense data, it's difficult to understand and follow, it's more complex, but if you have lightness, it's more intelligible. Okay, so this is the visualization wheel dimension. So we have abstraction and figuration. By abstraction means we use boxes and charts, and by figuration means we use real world physical objects. Functionality and decoration. Functionality means no embellishment, and decoration means artistic embellishment. Density and lightness. Density means it must be studied in depth, density, and lightness means understandable at a glance, lightness. For example, this graph, it shows some data. On the y-axis we have adjusted grade, certified above 60%, and on the x-axis we have percentage of chapters access. And this is 1000, this is in percentage, 0 to 100, and this is another percentage, and this is percentage of chapters accessed, and this is adjusted grade. So you see, it's very complicated data. It's difficult to understand the meaning of this data. So it's very important, like here we say density and lightness. So it's very dense. I mean, you need a lot of information to understand this graph. But if you go to the lighter mode, it will be easy for us to understand, for the audience to understand. Multidimensional and unidimensional. Multidimensional means different aspects of phenomena, and unidimensional means single or few items of phenomenon. For example, this one. This is just some tabular data, but complicated figure is drawn. So multidimensional, unidimensional, originality and familiarity. So this is original. I mean, novel methods of visualization is known as originality. But if you use familiar, established and well understood methods of visualization, so it's easy to understand. Novelty. Novelty means explaining each item once, and redundancy means encoding multiple explanations of the same phenomena. So this is what the wheel preferred by scientists and engineers. Normally they stay here. Their data is more abstract and their figures are more abstract, more functionality, density, multidimensionality, originality and novelty, and less on this side we focus. But if you go to the wheel that is favored by artists and graphic designer and journalists, normally their figures are more on this side and less on this side. So different professional backgrounds have different ways of facing projects. This is a book that's very interesting, The Visual Display of Quantitative Information by Edward Tufte, and it's very interesting book. Try to download this book and try to read the content of this book. It discusses different ways of quantitative information, how we can display. This is a website, and it's also gives some different figures, how to display information. So you can go through it and try to understand. For example, here is one case study. We have this figure, and we try to understand how to make it easy to understand. If you look to the data, there are multiple redundant information. For example, number of calories are here, and then calories per 100 gram for different foods. And then we have type of foods, and we have this different French fries, potato chips, bacon, pizza, chili dog, and we have these labels here. So how we can make it more easy to understand? Let's try to first remove background. So if you remove background, because this background is not very good, so try to use white background. Now remove redundant labels. So you see here we are talking about different food, type of food. Already these are food name of calories, and some food name. So we remove it and we make it simple, calories per 100 gram. Another thing we can do, we can remove borders. Okay, so if we remove border, it looks something like this. Much better than the first graph. Now colors are good to display, but we have to understand that there are some colorblind people, so they cannot understand different colors. So I mean, you can use patterns, but let's say simply if you use the grayscale. So you see here we go to a grayscale image, and you see we are having some special effects like shadow, which makes it look nice, but it's just extra information. The same information can be presented as removing the special effects. We can lighten labels. You see the labels are here lines, but we can do this. And what if we can put the labels on the bar charts like this? So I think this is more simpler figure. It's easy for audience to understand. So you can compare the difference between the two. The first figure has a lot of information that need to be processed, and the second figure, the same information is processed in a much simpler way. So this is just some more representation of the data. So qualities of a great visualization: one is truthful. Be aware of your actions when cleaning, summarizing, and manipulating data, and ensure you are not misleading yourself, like self-deception, and you are also not misleading your audience. So this is a very important quality if you are going to have a good visualization. For example, this data shows less regulation is equal to more industry investment. So from 1993 to 1996, when there was 1992 cable regulation, there was industry investment was 14 billion. But after regulation were relaxed, probably somewhere in 1999, the investment increased from this to this billion. However, if you look to this figure, so it's the cable industry infrastructure expenditure in billion, and you see in 1992, when there was Cable Television Consumer Protection and Competition Act, this is what is called regulation. So the information is somewhere up to 4 billion. From 4 billion, but here it is misleading. And then once there was regulation, the investment increased, but not all of a sudden. After 2023, you see, until 23, it was up to this much industry investment. There was some down and some up, but this image does not completely capture the full data, so it's misleading. There is self-deception as well as there is misleading of audience. Functionality, I mean, the same data can be performed by different function. So you see, here we have more functions, like we have labeled the data, we have drawn lines, and then we have labeled, but we can put these labels here and we can easily show the same information. Beauty, so beauty is important but not too much colors. Insightful and enlightening. Enlightening means the combination of the previous four, but with a social ethical responsibility. So all these are qualities of a great visualization. And after this lecture, we will go through Python library, matplotlib, and we will see how to perform visualization like plotting and charting. And here some different acknowledgements are given. In slide 1, we were using an image, so it was basically taken from this book. In slide 5, there was an image, we have taken it from this paper. You can read this paper, it's an interesting paper. And this is another chart that we use in slide number 7. And this is slide number 9, the functional art, an introduction to information graphics and visualization. It's also interesting to read. And slide number 10, the visual display of quantitative information. It's another book. And this is slide number 11, information is taken from the website. Slide number 21, it's another book. And slide number 2, another book. And slide number 25 and 26, 27, 29, all these information that we are using are taken from these papers or books. Okay, so thank you very much.